So in the video lecture, we saw a circuit that could clip certain portions of the an input voltage that we apply to that circuit. Okay, the circuit looks like this. I have a sinusoidal voltage source and I have a resistor. Alright, then I have, suppose, a diode and a voltage source. Okay, yeah, and the circuit works like this. So why does this circuit work like a clipper? Okay, we will try to explain that. Let me just draw here the input signal. So okay, I need to put in some values. Some assumptions I will be making in this lecture is that this diode is ideal. Okay, this is an ideal diode. All right, this is an ideal diode, and I can give some value to this voltage source. Suppose I give a value of 2 volt. Okay, so suppose I apply this signal. I can explicitly write this signal. Suppose this is a signal of the form like this, 10 sine omega t to the input of this circuit. Now what happens? What happens is that okay, so initially I can give a ground here. Okay, so initially suppose the voltage is rising. All right, the voltage is rising. Initially the voltage is 0 and it is going to 0.5 volt and 1 volt like this. Okay, so when the voltage of this point is 1 volt, suppose the sinusoidal voltage, the point of this voltage is 1 volt. Okay, so in such a case, is this diode on or off? Can you think about that? Whether the diode that I drew in this circuit is in the on condition or in the off condition. Okay, the diode will be actually in the off condition. Why is that? Can you think? Because for a diode to turn on, the voltage of the anode needs to be greater than the voltage of the cathode. All right, so what is the point of this voltage? What is the value of the voltage of this node? If this node is the ground node, then this node will be at the 0 voltage point, and the value of this node, the voltage of this node, not the value actually, the voltage of this node will be 2 volt, and the voltage of this node is 1 volt. You see, the anode is connected to a lower voltage point than the cathode, so this diode will remain off. All right, this diode will remain off. If the diode is off, then an off diode works like what? It works like an open circuit. So we can just redraw the circuit using an open circuit like this. Okay, the diode is off, so the diode will act like an open circuit, and I have a voltage source here. Yeah, just like this. Okay, so I have some voltage in the input, right? I have some voltage in the input. What will be the output voltage? Can you tell? Suppose if I have an open circuit condition like this, you can just think of, suppose I have a voltage source and I have a resistor and I have an open circuit at the front, and I connect a voltmeter to this open circuit. What voltage will I see? Well, I will see exactly the same voltage as the input. Whatever voltage I put in the input, it will come directly to the output. Why? Because there is no current flowing in this circuit. Since there is no current flowing in this circuit, there is no voltage drop across this resistance, right? Because I is 0. If I is 0, then what V in is, it will directly come to V out. Okay, V out equals V in. So whatever I put in the input, I will see at the output. As long as when will this happen? If the open circuit condition persists, then this will happen. And when will the open circuit condition persist? If this diode is off. So as long as the diode is off, whatever I put in the output, I will see the same voltage at the, whatever I put in the input, I will see the same voltage at the output. Okay, so my output is rising with the input. As I said, the input is rising and the output is rising with it. Now suppose my input comes to the 2 volt level. Okay, let me write this in blue. My input rises to 2 volt. Well, let's say greater than 2 volt. Suppose 3 volt. Okay, now if the input is at 3 volt, can you tell me whether this diode will be on or off? Well, you see, the anode of the diode is connected to a higher voltage than the cathode, right? The cathode is at 2 volt, but the anode is connected to a voltage that is at 3 volt. So the diode will become on if it is at 3 volt. And an on diode, since we are assuming that the diode we are using is ideal, then an on diode is actually equivalent to a short circuit. So if we draw this circuit with a short circuit, it will look like this. Okay, I will just give this a short circuit here, and then I have my voltage source. This voltage source is equal to 2 volt. Okay, and this is the output terminal. So can you tell me what is the voltage of the output terminal if this diode is short? Can you tell me if this is the ground? Well, we knew that the point of this node, the voltage of this node is 2 volt. Since this node and this node is now short, then this node's voltage will also be 2 volt, right? Because they are short circuited. We know that if two nodes are short circuited, then they are at the same voltage. If this is at some voltage V1, then this is also at that voltage V1. So if this node is at 2 volt, then this node will also be at 2 volt. That means this node will also be at 2 volt. So what will be the output voltage? The output voltage will be 2 volt, exactly equal to the voltage source that we had. So as long as this diode is on, as long as our initial diode is on, alright, as long as our initial diode is on, our output voltage will be constant. It will always be at 2 volt, right? It will always be at 2 volt. Now, when will my diode remain on? Well, my diode will remain on as long as the anode of the diode is at a higher voltage than the cathode. Now, we can see here that the cathode is at 2 volt. So, for all voltages of the input that is higher than 2 volt, my diode will be on, right? For all voltages of the input, my input voltage goes from 0 to 10, then it again returns to 0, then it goes to minus 10, okay, then it goes to minus 10, then it goes to 0, and it keeps cycling like this. Okay, so for all voltages greater than 2 volt, okay, for all voltages greater than 2 volt, my diode will remain on, and as long as my diode remains on, my output will remain fixed at 2 volt. So what will the output look like? The output will look like, suppose this is my 2 volt level. So the output will remain constant at 2 volt. The blue part of the graph is my output. As long as the input is greater than 2 volt, my output will be constantly at 2 volt. Now the input is rising, it goes to 10 volt, then it starts decreasing again. And if the input now decreases below 2 volt, if the input now falls below 2 volt, then what will happen? Well, the diode will turn off again, right? As we know that the diode will remain on only if the input is greater than 2 volt or input is greater than the voltage source that I am using. Alright, so if the input falls below 2 volt again, then the diode will turn off again, and if the diode is off, then the output voltage will again be equal to the input voltage. Okay, so if the input falls below 2 volt, the output will again start to follow the input voltage. All right, simple as that. Okay, and this cycle will continue. So you can repeat this argument for any voltage of this value. Okay, so this is how the positive clipper works. Okay, and how the negative clipper works? The negative clipper works in exactly the same manner. Okay, let me just repeat the argument shortly for the negative clipper. Okay, in a negative clipper, the diode is, oh sorry, the previous one was the negative clipper, this is the positive clipper. The diode is connected downwards. Okay, and I have a voltage source like before, 2 volt. Okay, and like before I have an input signal. Yeah, and I can represent the input signal like this, exactly like before. Suppose my input signal is 10 sine omega t. Now what will happen? Okay, so if my input is, suppose my input is at 1 volt. Did I draw it correctly? Oh well, I drew the diode in exactly the same direction. I need to reverse the direction of the diode. Sorry for that. The diode direction will be like this. Okay, all right. So if yeah, suppose my input is at 1 volt now. My input rises, you see the input rises and then falls and then rises again. Suppose my input is rising, my input comes to 1 volt, rising from 0 volt to 0.5 volt to 1 volt to 1.5 volt, etc., etc. My input is now at 1 volt. Will this diode be on or off? Can you tell me? Suppose this is the ground. Well, what is the voltage of this point? As before, the voltage of this point is 2 volt. Okay, so when will a diode turn on? A diode will turn on if the voltage of the anode is greater than the voltage of the cathode. So the anode is at 2 volt and the cathode is connected to a 1 volt potential. Okay, connected to a point that is at 1 volt potential. Suppose for the time being, even if some drop occurs across this resistance, then this point will be even lower than 1 volt, right? So in any case, this point will be at a lower potential than 2 volt. Okay, so since the cathode is at a lower potential than the anode, then the cathode will turn on. All right, if the cathode turns on, as before, I can replace it with a short circuit. I have a resistance and I can draw a short circuit here. Okay, I can draw a short circuit and I have my 2 volt voltage source. Okay, so what will be the output voltage now? Now the output voltage will be 2 volt, because since this is a short circuit, the voltage of this node was 2 volt. Since it is short circuited, the voltage of this node will be 2 volt and the voltage of this node will be 2 volt. Okay, so the output will be at 2 volt. If my input is at 0.5 volt, what will happen? For 1 volt, I see that my output is at 2 volt. If my input is at 0.5 volt, what will happen? Well, it is still lower than 2 volt, right? The input is lower than 2 volt, then the diode will remain on, then the output will be also at 2 volt. As long as the input remains below 2 volt, okay, in the previous circuit, we saw that as long as the input remained above 2 volt, the output remained at constant 2 volt. In this circuit, as long as the input remains below 2 volt, the output will remain constant at 2 volt. All right. So if I draw the 2 volt level, suppose this is the 2 volt level. Okay. So for all voltages below 2 volt, the output will be at 2 volt. Okay. All right. Now what happens if my input voltage is greater than 2 volt? Suppose my input voltage comes to 3 volt. Can you guess what will happen? Well, now the cathode is connected to a potential, to a voltage that is higher than the anode voltage. Anode is a 2 volt and the cathode is connected to a voltage that is 3 volt. Okay, so can the diode remain on now? No, it cannot. So if the diode cannot remain on, I can draw the circuit like this. The diode will become open circuit, and the diode will become open circuit, and there will be the voltage source as before. Okay, yeah. So what will be the output voltage now? Well, since this is open circuit, this voltage source will contribute nothing to the output, and whatever is in the input will come directly to the output. Okay, this will come directly to the output. So V out will be equal to V in. So all voltages above 2 volt will pass exactly the same as it is in the input. So all voltages above 2 volt will pass exactly as it is in the input. So since for 3 volt it remains on, the diode will remain on for all voltages that is greater than the cathode voltage. Greater than the anode voltage. Okay, for all voltages greater than the anode voltage, the diode will remain on, and well, for all voltages greater than the anode voltage, the diode will remain off. Okay, if the cathode voltage is greater than the anode voltage, the diode will remain off. If the diode remains off, then the input voltage will pass exactly to the output, and well, yeah, that's about it. So this is how the clipper configuration works. Okay, if you draw the clipper downwards, then depending on the value of the voltage source, if the voltage source is at the 2 volt value, then for all voltages greater than 2 volt, the diode will remain on and the voltage will be clipped at 2 volt. And for this configuration, for all voltages below 2 volt, the diode will remain on and the voltage will be clipped below at 2 volt. Okay, so this is the negative clipper, and the upper one was the positive clipper. Okay, so this was the explanation, but to remember, you can just see the direction of the diode. Okay, since the diode is pointing downwards, that means that all voltages below 2 volt will be allowed to pass. You see that all voltages below are passing, all voltages below 2 volt are passing, and in the next configuration, the diode is pointing upwards, so all voltages above 2 volt will pass. You see that all voltages above 2 volt are passing. Okay, thank you. So in the next lecture, we will be seeing another type of signal processing circuit that we can make using diodes. So again, thank you very much, because you are curious enough to learn how the circuit that we are using is operating. I hope that you that everything was clear, that you understood how this circuit is operating when the diode is turning on and when the diode is turning off. As I said earlier, that you won't be asked to explain how a clipper circuit works, but you will only be asked to design a clipper circuit to perform a specific task. Okay, so I hope it was clear. I was able to explain. Sorry for messing up all the diode on and off terms. Okay, hopefully that didn't cause much confusion. Thank you for being with me. See you in the next lecture. Bye.